Let's see. You hear me? Okay, good. I wasn't planning to pretend or present anything here today, and I even put on my incognito suit because I believed I'll try. If I put this on, no one will want to talk to me because they don't think I know tech. That was my sort of entry into this. I can hide in the corner and just be antisocial the entire time. But then I saw on Monday the anti-forensic talk by Stefan. I don't know if he's still here, but he presented the forensic artifacts and this kind of thing with such enthusiasm and such passion. I thought I can share a little something, maybe something fun. So I have a small little section where I'll cover that, because in reality I've been doing forensics and incident response for the last 7 years, and to the point where it's like when you've done your 20th Akira case, it's not that fun anymore. It's pretty much the same thing over and over and over, just slight variations. So I thought it's nothing fun to share, but I do have some fun things to share. So I'll cover one of those examples here. This is the Windows Task Scheduler. This is a custom handler. It's a task called reg idle backup. This is from this computer earlier or later or yesterday, something like that. You probably have it on your PC. It's built in. It's native. It's used to serve as the function to perform a backup of the registry. Nowadays, it performs a broken backup of the registry, but it still runs. It doesn't do anything. And it's either way not the point. The point is the highlighted part, the custom handler. I think a talk in an hour or two is going to cover this in more depth than I will have to cover, so you'll get a better explanation of what that is. If you try to modify this as is, you just get an error saying this is a system-level task. You can't really do anything with this. But that's not actually really true, because what you can do, this is just how it looks like, by the way, in the version when it was patched. So already here, some of you, both on the red and on the blue side, should maybe start getting some thoughts, some ideas. Maybe you can work something out here. This is how it looks under the hood. So scheduled tasks are essentially XML files which defines how they work. And what if you can modify those files? Because those are not system level protected in the way that the task scheduler is restricted. So what you have here is something that looks exactly the same almost. The only thing that differs is the GUID, and that's wrapped in a COM handler, which is something. Let's ask Microsoft of their definition of that, because it's tricky to explain in a short minute. But what we want to pay attention to is the left side. Let's see the last four values there on the GUID. So CA68. Let's keep that in mind. But first, what does this mean? We ask Microsoft. They summarize it, some smart code. This is official documentation right now. So it doesn't help us very much. So let's just ignore that and pray that, I think Julian, if I spell it correctly, is going to explain this better to us in an hour or a couple of minutes. But let's move on and see, where does this take us? And the way it works is this is just a pointer, essentially. It's more complex than that. It's the component object model and so forth, but it points to a location in the registry. If you're a blue side, this is where you want to go and have a look and see, is there something here? So what we see on the left side is the key, and there's a subkey which says treat as, which just means exactly what it kind of states. Treat this as something else. So it points to another GUID, another value, which is on the right side. So we go there. We look, and this is what we get. Let me zoom in a little bit. And on the left side, you see this new GUID, or this new class ID, as it's called, which its own levels of subkeys. And the first one we look at is the local server. And on the top side there, you see that there is some reference to something that looks potentially bad or interesting at the very least. There's some PowerShell stuff, typical bad stuff, potentially. So we zoom in on that part and try to figure out what that means. Top part is exactly what it looked like, and we just decode that to see what it's actually doing. And what we find is that it's some invoke stuff, some execute some things, and it's another pointer to another location in the registry. This time it's the same class ID, it's just another subkey. It's the prog ID, which we saw in the previous screenshot, right? So we go there, and we have a look, and now we see some more stuff again here on the right side. Some function, something going on, and this was a large blob of code with a lot of obfuscation and smart techniques, which I'm not going to cover now, but basically what it boiled down to was that's just me zooming in on this to show that it's, for those of you who have poor eyesight like I do. But this is the core part of what was really happening there, and in simplified terms, this is basically just a method of building a C# project in very simplified terms. I'm not a coder. But what they had done was within this project, which we have saved for reversing purposes, and it's still today barely anything that detects it. They had built a type of remote access Trojan using covert channels as part of the build process that would run when you would build the project using MS Build. So you're executing your code using legitimate native tooling, essentially. And what they've done is that as part of this communication, they used domain fronting, and basically used a CDN to cover their C2 infrastructure. So there was no IP address, there was no domain that you could use to pinpoint where this came from, because they were going through a CDN. In this case, it was Microsoft's Azure Edge, which is now retired earlier this year. But what you have here now is a situation where you have a native Windows task modified, it's a system level task that shouldn't be touched, it shouldn't be modified, but it has been modified. At this point, it had left no traces in no logs available. We had to do some thorough digging to find this. If you look at the network side of things, you see communication to Azure or Azure Edge, Microsoft CDN, or that they'd used before. So you don't have a lot to go by. But the title is the threat actor tripping on the finish line. So what do you do as a threat actor if you have a persistent remote access method that lives in memory using covert communication channels that the at the time installed EDR, antivirus, and so forth did not detect at all? What's the next step you do as a threat actor? Naturally, you deploy a broken Cobalt Strike PowerShell command that every single EDR and antivirus in the world detects, and you get spotted and you fail miserably. That's all. Thank you.